Everyone, my name is Nidhi. I am assistant professor in Gyan Vihar School of Pharmacy. That is a part of the Suresh Gyan Vihar University, Jaipur. So today we are going to discuss the alcohols. So alcohols is come in your pharmaceutical organic chemistry first, any of the pharmaceutical semester, or you can say the B.Com first year. So here we are going to start the topic. So today So here we are going to learn about alcohols, and also we are going to study about the chemical reactions of alcohol. What are the chemical reactions of alcohol and the student outcome that they will going to know about the alcohol, that what is alcohol, and also they are going to learn about the chemical properties, or you can say the chemical reactions of alcohol. So the alcohols are generally the compounds, the organic compounds, which are having the OH group attached to the organic chain. So in this, the OH group, that is your in the alkane, if the E is replaced by the all that you can see in this alcohol suffix all. So this all replaces the E from the alkane and it became alkanol. So the alkanols are the alcohols, or you can say that when OH group or the hydroxy group is attached, OH group is also called the hydroxy. The hydroxy group or the function group, OH function group is attached to the chain, any organic compound hydrocarbon chain, then it becomes an alcohol. Let's study the chemical reaction. Chemical reactions of alcohol, as we know that alcohol acts both as nucleophiles as well as the electrophiles. Nucleophiles means the neutral loving, means they are neutron loving, so they have the capability to donate electrons to the electrophile or the electron deficient atom or group. So the nucleophiles are those compounds. They are those atoms or the groups which are having electron donating capability, or as well as electrophile. Electrophile means they are having the capability of electron accepting. So they accept the electron from the nucleophile. So these alcohols, they are acting as both, means they are acting as nucleophile as well as an electrophile, and the bond between your OH is broken when alcohol reacts as nucleophile, and the bond between the CO is broken when they act as a electrophile. Means here the bond between OH is broken when alcohol reacts as a nucleophile. As you know that oxygen is having a pair of electron pair, so this oxygen is acting as a nucleophile to donate its electron to another atom. So this OH bond is going to break. After that, it will act. The oxygen will act as a nucleophile, and the bond between the carbon oxygen is broken when they react as electrophile. Means in the carbon and oxygen, there is a double bond between this carbon and oxygen. So uh, when this CO acts as an electrophile, means the oxygen will withdraw the electron from the carbon atom, and this carbon, this carbon will act as a nucleophile, and it will act as an electrophile. That is why the bond between the carbon and oxygen breaks, and there's a this carbon acts as a electrophile. So the chemical properties of any given aliphatic alcohol depend upon the nature of the alkyl group and on the properties of the hydroxyl group based on the cleavage of the OH and the COH bond and the reaction of alcohol with carrier means here the chemical properties, this chemical property of the aliphatic alcohol. Aliphatic alcohol, aliphatic alcohols are the alcohols in which the carbon chain is attached. So in which the carbon chain is there and there is the OH group is attached to the chain, that are the aliphatic alcohol. And the phenyl alcohol, in which the benzene group or the phenyl group is attached, and then on that they are OH group is attached. They are the aryl alcohol or the yes, aryl alcohol. They are known as aryl alcohol. So the chemical properties. So here we are studying this aliphatic alcohol. So the chemical properties of this aliphatic alcohol is depending upon the nature of the alkyl group and on the properties of the hydroxyl group. So this chemical properties of any given aliphatic group is dependent upon the nature of alkyl group as well as the property of the hydroxyl group. So the in the aliphatic alcohol there are two things. Means one, the OH group is attached, and the second is the hydrocarbon chain is there. Means there is an alkyl group chain in that compound. So the chemical property. So that is why the chemical property of this aliphatic alcohol is dependent upon the nature of the alkyl group, nature of the alkyl group, as well as on the properties of the hydroxyl group, as well as on the properties of the hydroxyl group. So these alcohols are acting as both as nucleophile as well as the electrophile, and the bond between this oxygen and the bond between this oxygen hydrogen is broken when alcohol reacts as nucleophile, and the bond between the CO is broken when they react as electrophile, and the chemical. So this that is why this alcohol is acting as a nucleophile and the electrophile, because there is the presence of this oxygen as well as the carbon. The oxygen is acting as a nucleophile and the carbon is acting as a electrophile. So the chemical properties. So that is why the chemical properties of this aliphatic alcohol is depending upon the nature of the alkyl group, the nature of the alkyl group as well as the properties of the hydroxyl group. The chemical properties of this given aliphatic alcohol is depending upon the nature of the alkyl group, that what kind of a alkyl group is attached, and the hydroxyl group properties. So the what kind of the properties of this hydroxyl group is having. So based on the cleavage, means based on the cleavage of this OH, means if this OH is breaking from there, then based on that and COH and the COH bond, that is the hydroxyl bond. So the reaction of alcohol, that is why the reaction of this alcohol is depending upon, may be divided into your two types. Here it is divided into the two groups, and the reaction involving cleavage of oxygen hydrogen bond. So here the first reaction is occurring as there is a involvement of the cleavage of this oxygen hydrogen bond. First reaction is the acylation of alcohol. Means there is a acylation of this alcohol. So when this alcohol is reacting with the acyl halide, means they are reacting with this acyl halide and anhydride substitution. When the alcohol is reacting with the acyl halide and the anhydride substitution of hydrogen atom by the alkyl acyl group is known as acylation of alcohol. So in this, when alcohol is reacting with, जब alcohol react, when the alcohol is reacting with your acyl halide, means it is reacting with your acyl halide and anhydride substitution of hydrogen atom. So there is a substitution of hydrogen atom by this acyl group. This substitution of hydrogen atom is known as the acylation of alcohol. So this is the acylation of alcohol. When alcohol is reacting with the acyl halide and there is a formation, no, there is a substitution of hydrogen. There is a substitution of hydrogen from the alcohol by the acyl group, then that is known as your acylation of alcohol. So again, this chemical reaction of this alcohol is acting as both as nucleophile and the electrophile. So the nucleophile means the atoms or the groups that are electron donating or the electron uh, donating or they have the electron pair present on them, so they have the capability to donate electrons to the atom or the groups which are having deficiency of this atoms or group. So they are known as your nucleophile. And the electrophiles are those groups or atoms that are groups or atoms that are having a deficiency of electrons or deficiency of electrons. So they need electrons. That is why they are the electrophiles means uh, electron loving, and nucleophile means neutron plus loving. So these alcohols are acting as both. Means they are acting as both. Means they are acting as nucleophile as well as the electrophile because they are having an oxygen and carbon present in their structure. So that is why they are acting as both a nucleophile as well as a electrophile. And the bond that is between oxygen and hydrogen means the hydroxyl group. So in the hydroxyl group there is the oxygen and the hydrogen. And when this oxygen and hydrogen is broken, and when there is a breakage in this oxygen and hydrogen, then alcohols react as, so in that case the alcohol is reacting as nucleophile. um, when the bond between this oxygen and hydrogen is broken, means when this bond hydrogen and oxygen is broken, then this oxygen is acting as a nucleophile. So in that case, this alcohol is acting as a nucleophile because in that case the oxygen is having a lone pair and it will donate its electron to that atom or group which is having the deficiency of electrons or deficiency of electrons. So this alcohol is acting as a nucleophile, and the bond between this CO is broken, and the bond between this CO is broken uh, when they react as electrophile. When they react as electrophile, so the bond between this CO is broken when they react as electrophile. So this CO, when this bond CO is broken, means here the carbon which is have this whose electrons is taken by the oxygen, so it becomes your electro deficient. So this carbon electron is withdrawn by this oxygen, and it is having the partial positive charge in this oxygen will get the partial negative charge. So this carbon will act as an electrophile. This carbon will act as an electrophile, and they will react as this carbon will react as a electrophile. So this will react as a electrophile. And the chemical properties. So the chemical properties of this aliphatic alcohol, the chemical properties of this given aliphatic alcohol depends upon the nature of the alkyl group and the properties of the hydroxyl group. That what is the nature of the alkyl group and what are the properties of this hydroxyl group. So based on that cleavage, means based on the cleavage between this OH and this COH bond, the reaction of alcohol may be divided into two groups. A is your reaction that is involving the cleavage of OH bond, means the reaction that is involving cleavage of oxygen hydrogen bond, the reaction that is involving the cleavage of oxygen hydrogen bond. So first, in that case, the first reaction is the acylation of alcohol. So the first reaction is the acylation of alcohol. So in this, when alcohol is reacting with the acyl halide and anhydride, the substitution of hydrogen atom by acyl group is known as acylation of alcohol. So this is known as acylation of alcohol. So acylation, here you can see when this alcohol is reacting with this acyl halide, or this alcohol is reacting with this anhydride, that is acetic anhydride. Then they are forming this, there is a acylation of alcohol is happening. Means there is a substitution of hydrogen atom. This hydrogen is um, is moved from here and it will get reacted with this Cl. So this H will react with this Cl portion. And there is a formation of this HCl. The formation of this HCl. And this RO react with this CH3CO RO, and this is known as the acylation of alcohol, because this H is substituted by this acyl group, that is your CH3CO. So this is substituting this hydrogen, and this hydrogen is reacting with this Cl, and there is a formation of this HCl. In the similar case, in this acetic anhydride also, this is your acetic anhydride, and they are the molecules of the CH3CO whole twice. So here CH3CO whole twice. So CH3COO, CH3CO. In this case, CH3CO will react with this. We substitute this hydrogen from here and it get attached to this RO, and here the CH3CO will react with this H, and there's a formation of this acetic acid plus this acyl compound is formed here, and this H is replaced by this acyl group, that is a CH3CO. So this will react with this RO, so there is a formation. So that is why acyl group, that is why the reaction is known as your acylation of alcohol. So this is the first reaction of this reaction involving the cleavage of this OH bonds, and this is due to the chemical properties of any aliphatic alcohol, that is depending upon the nature of the alkyl group as well as the properties of the hydroxyl group, and there is a presence of nucleophile as well as the electrophile, and this alcohol is acting as both, means as a nucleophile also as a electrophile also. So this is the first reaction that is involving the cleavage of this OH bond. Next is your reaction that is involving fission of ROH bond, means there is a cleavage of this CO bond, and there is a cleavage between this OH. So here there is a reaction that is involving the fission of this ROH bond. There is a cleavage of RCO bond. So the reaction involving ROH bond with cleavage of CO bond are as follows. So the reaction involving ROH bond with cleavage of CO bond are as follows. So first reaction is your dehydration. In the dehydration, intermolecular dehydration. So this is your intermolecular dehydration. In this, we are forming alkenes. There is a formation of this alkenes. So in the dehydration, alcohols undergo dehydration to form unsaturated hydrocarbons on reacting with a protic acid, means here hydrogen H2SO4 or H3PO4, or catalyst such as anhydrous zinc chloride or Al2O3. In the reaction, the OH and an H group removes from an adjacent carbon. Since water is removed from the alcohol, this reaction is known as a dehydration reaction or an elimination reaction, and the secondary and tertiary alcohol are dehydrated under much milder condition, and the condition for dehydrating alcohol depend closely on the structure of individual alcohol. So in the reaction involving fission of ROH bond. So here I have already in the last slide I have told you that there is a two type of reaction. That is, in first reaction it is involving the breakage of your COH bond, and the second is your OH cleavage. So the OH cleavage, in the OH cleavage, we have already seen that there is the acylation of alcohol. In that, there is a breakage of this OH bond. Next, in this, there is a cleavage of this CO bond. So in the CO bond, the reaction involving ROH bond with cleavage of CO bond are as follows. So in this ROH bond, so in this there is a reaction that is involving the ROH bond, and there is a cleavage of CO bond. CO bond are as follows. So there is a cleavage between. So there is a cleavage between this CO bond, which is as follows. So in this CO bond, there is a first reaction, that is your dehydration of alcohol. So in your dehydration of alcohol, first reaction is your intermolecular dehydration. Means there is a intramolecular dehydration. Means there is a molecule, there is a dehydration, and there is a formation of a alkene. There is a formation of a alkene. So alcohols when undergoing this dehydration, there is a formation of this unsaturated hydrocarbon, and in that condition, we are treating this alcohol with the protic acid. That protic acid may be your H2SO4, means sulfuric acid, or your phosphoric acid, that is your H3PO4, or catalyst, or in the presence of a catalyst, that is such as your zinc chloride, or Al2O3 or Al2O3. And in this reaction, the OH and the H group, and in this reaction, the OH as well as your OH as well as your H group will remove from the adjacent carbon, means from the neighboring carbons, and due to which there is a removal of water from the alcohol. That is why this reaction is known as a dehydration reaction or an elimination reaction, because in this there is an elimination of this H and OH groups are occurring, and in the secondary and the tertiary alcohol are dehydrated. In the secondary and the tertiary alcohol are dehydrated under much milder condition. So in this they are dehydrated under much milder condition, and the condition for dehydration means if there is a dehydration of alcohol is occurring, then there is a condition, and that condition is depending closely on the structure of individual alcohol. Means what type of a structure is there in the alcohol. So it is depending on that. It is depending on the structure of individual alcohol. And for primary alcohol, the condition required are concentrated sulfuric acid and temperature of 170 degrees centigrade. And the temperature means in the primary alcohol case, if there is a dehydration is occurring, then there should be a concentrated concentrated sulfuric acid should be there, as well as there should be a temperature that should be 170 degrees centigrade. So then only there is a dehydration of alcohol will occur. So here in the dehydration, this is an intramolecular, means it is occurring in your molecule only. This intramolecular means that this reaction is occurring in your molecule, means in the one compound, one organic compound, and when this one organic compound is reacting with a reagent as well as your catalyst, then there is the formation of the alkene, or you can say an unsaturated compound is formed, because this alkene is unsaturated hydrocarbons, and there is a removal of this H and OH from this compound, and there is the formation of this alkene, means there is a formation of this double bond is formed. Again, I'm repeating this, means in the dehydration, there is an intramolecular dehydration, means in that hydrocarbon in that compound there is a dehydration is occurring, means there is a removal of the, but means there is a intramolecular in between the molecule only, one molecule only. There is no need of the another compound for the dehydration. In one molecule, in the one molecule, there is a dehydration is occurring. So in the intramolecular dehydration, there is a forming alkene. There is a alcohol. Alcohol is undergoing dehydration, and there is a formation of the alkene, there is a formation of the unsaturated hydrocarbon, means alcohols are undergoing dehydration, and there is a formation of the unsaturated hydrocarbon. And if we are treating this alcohol with the protic acid means there is a presence of this hydrogen. And so, for example, protic acid is your H2SO4, it is your concentrated H2SO4, or phosphoric acid, or a catalyst, that is your zinc chloride, or your catalyst that is your anhydrous zinc chloride, or your alumina that is your Al2O3. So here this alcohol we are reacting this alcohol with the reacting this alcohol with this protic acid. We are reacting this alcohol with this protic acid, and for example is your H2SO4 or your H3PO4, or catalyst that is such as your or anhydrous zinc chloride or Al2O3. And in this reaction, there is a in this reaction the OH and the H group. So in this reaction, the OH and the H group removes from the adjacent carbon from the neighboring carbon, and there is a removal. There is a water is removal from this alcohol, and the reaction is known as your dehydration reaction or an elimination reaction, because there is a elimination of this hydrogen and the alcohol OH group from this adjacent carbon. And the secondary and tertiary alcohols, this tertiary secondary and the tertiary alcohols are dehydrated under much milder condition, and the condition for dehydrating alcohol depends closely on the structure of your individual alcohols. And for primary alcohol, there should be a condition, and that condition should follow that. A requirement for that condition is that there should be concentrated H2SO4, as well as the temperature should be of 170 degrees centigrade. Next is the reaction. So here you can see this ROH, and in the ROH, this is your protic. Means there is an acidic H positive, and in the there is a formation of this water molecule, this H2O. And when this water molecule is removed out from here, then it becomes R positive, and R positive, and R positive will mix up, and there is a formation of this alkene. Next, in the example, you can see here, this example is given CH3, CH2, CH2, CH2OH. So from this, the H positive, this H positive is reacting, and there is a formation of this OH group from here, and there is a formation, of this double bond between this carbon. Again, from here, you can see this H and the OH is removed out from here, and there is a formation of this double bond where alkene is formed between this carbon and carbon. Next is this is your cyclo compound, and in cyclo compound, the CH2OH is attached to the cyclobutane, and when there is a removal of this water molecule, means there is a dehydration of water molecule. You can see there is a formation of this cyclopentene. So it is involved. The CH2 is also involved in this. In this group, in this ring. So here in this, you can see that it means this is your acid. And when this acid is taken up by this OH, There is a, this OH is removed, this H is removed. So here there is a formation of this double bond will occur. Means here this is your primary, and when this primary, this is your secondary. So H will shift from here. So there is a shifting of hydrogen. So they become HCS3, and between this carbon and this carbon, there is a formation of the double bond. Next, in this, there is your this carbon atom, and in this there is a H, and OH is removed out from here. Means here H2O is removed out from here, and between this carbon and this carbon there is a formation of the double bond. Next is your this CH2OH. So in this this is a cyclo compound, and in this also there is a addition of this hydrogen, and there is a formation of this cyclopentane compound. Next is your, in smaller ring, always in smaller ring, always ring expansion takes place due to the molecular strain, and they tend to convert to high stability with larger rings. So here in this case, you can see in the smaller ring, means in small ring there is a ring expansion. So there is a ring expansion occurs in the smaller ring, and due to the molecular strain, due to the molecular strain, there is a ring expansion occurs in the smaller rings, and they tend to convert to high stability with large rings. So they are converting it into the larger ring due to the high stability. So in the smaller ring, there is always a ring expansion takes place, and due to the molecular strain, they tend to convert to high stability. They tend to convert to high stability with large ring. They tend to convert to high stability with large ring. So there is a formation of this. There is a formation of this larger ring. So here you can see this is a cyclopentanol, and this here when this high acidic H positive will react, there is a removal of this OH from there. So there is a positive sign on that. After that, there is a shifting of this CH3 from here to that compound, and to that side, and here again from there this H is removed out from this side. This H is removed out. There is a positive charge, and from here this H is removed out from this side. So there is a double bond. So it can be removed from this side also and from this side also. So there is a formation of two products, that is your major as well as your minor product. Next is your secondary alcohol. So secondary alcohol dehydrate under milder condition than primary alcohol. So secondary alcohol dehydrate under mild condition. So here it is also dehydrating under milder condition, and then your primary alcohol. So here this is your secondary alcohol, and when this secondary alcohol is reacting with your H3PO4, that is a phosphoric acid, then there is a formation of this. There is a formation of this cyclopentene. Sorry, cyclohexene. So this cyclohexene is formed, and here the cyclohexanol is converting to the cyclohexene at the temperature of 160 to 170 degrees centigrade. So this is cyclohexene is formed while water molecule is formed. So secondary alcohol is dehydrated under milder condition than primary alcohol, and this OH, this cyclohexanol is uh, formation. There is a cyclohexanol is reacted, or this is reacted with this phosphoric acid. This is a protic acid, and at a temperature 160 to 170 degrees centigrade, and there is a formation of this cyclohexene, thus H2O is formed. Next is your tertiary alcohol. So tertiary alcohol is dehydrated under even milder conditions. So here it needs 20% H2SO4, and there is a formation of this alkene. So this alkene is formed here. So the main function of the acid, so the main function of this acid is to transform the poor leaving group OH into the very good leaving group OH2. So here, due to the acid, there is a transformation of the poor leaving group. Means from here, the leaving group, that is your OH, is is leaved out, is leaved from here, and there is a formation of this. It is converted into the OH2, and the order of the relative age of dehydration of alcohol is tertiary alcohol, then your secondary, then your primary. Because the tertiary carbocations are more stable, and therefore they are easier to form then the secondary and the primary carbocation and the tertiary alcohol are the easiest to dehydrate. So they are dehydrating under more even milder condition as compared to your or secondary alcohol or your primary alcohol. So in this is a tertiary alcohol, and this tertiary alcohol is dehydrating in the presence of this 20% H2SO4, and there is a dehydration of this, and there is a formation of this alkene. So here you can see that from here this OH is removed out, this OH is removed out from here, and there is a formation of bond between these two carbon atoms. This is having the positive charge on it if this is leaved out from here, and from here also this H is removed out, and there is a formation of this H2S. This double bond is formed between this carbon atom. So you can write like this also. The structure you can write like this also. Next is the main function. The main function of this acid is to transform. So the main function of this acid is to transform the poor living group. Means from here, the poor living group is leaved out, and this OH into a very good living group. So this OH is removed out from here into a very good living group, that is your OH2. So this OH is removed out, and there is a this OH2, and this OH is formed into your OH2. This is your water molecule, and the order of the relative age of the dehydration of alcohol is tertiary, then secondary, and then primary. Means the tertiary alcohol or the tertiary carbocation, this tertiary carbocation are more stable carbocation, more stable. This tertiary carbocation are more stable, and therefore they need these are more stable carbocation. Therefore, they are easier to form. They are easier to form the secondary and the primary carbocation, and the tertiary alcohol are the easiest to dehydrate. So they are easiest to dehydrate as compared to your secondary as well as your primary carbocation. Next is the order of stability of the carbocation is your tertiary carbocation, then your secondary, then your primary, and the normal HCH3. So here the dehydration of your secondary and tertiary alcohol contain more than 3 carbon atoms. It contains more than 3 carbon atoms, which will give a mixture of alkene, and the major product can be determined from Seng's rule. So major product can be determined from the Seng's rule, and the Seng's rule says that when an alkene is produced in an elimination reaction, so in the elimination reaction, when an alkene is formed, then the major product is the one. In that case, the major product is one with the more highly substituted double bond, with the more highly substituted double bond, and the major product is that contain the higher number of alkyl groups attached to the C double bond C. So here, the order of stability of the carbocation is this tertiary, then secondary, then primary, then your this simple alkyl group, and this dehydration of secondary and tertiary alcohol contains more than 3 carbons. So they are containing more than 3 carbon atoms, and it will give a mixture of, and this will give a mixture of your alkene. So they are giving the mixture of your alkene, and the major product can be determined. So the major product can be determined from the Seng's rule. So the major product can be determined from the Seng's rule, And the Seljuk rule says that when an alkene is produced from this alcohol due to the dehydration or in an elimination reaction, then the major product will be that product in which there is more highly substituted double carbon. Then the major product is the which uh, one with the more highly substituted double bond, that is the major product that contains the higher number of alkyl groups attached to the C double bond C bond. So in which the C double bond C bonds are highly attached with the alkyl groups, then that product is the major product of the major product that is formed from the elimination reaction or the dehydration reaction. So here you can see that this is your compound, this is your alcohol, and from there here this H is comes, and here this forms there is a formation of the water molecule. So it will this oxygen will withdraw the electron from this carbon, and this carbon will get the discharge. So here this it will so here it will get the net positive charge. So this H will remove off from here, and there is a formation of this double bond is formed here. So both the carbon gets the hydrogen, 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 hydrogen plus your H2O plus this H positive that is removed out from this carbon atom. So there is a formation of this alkene, this unsaturated compound from this alcohol. So here this H is having a free radical. So this oxygen, it will get attached to this oxygen, and there is a removal, there is a formation of this water molecule. So this oxygen will withdraw electron from this carbon atom, and there is a formation of this compound is formed here, and there is a formation of this double bond. Next is this is the reaction that is given. So in this there is a water removal. So here from here there is a water is removed from here. From here the water is removed from here, and after that this alkyl, this is your secondary carbocation. This is your secondary carbocation. So this is your tertiary carbocation. So tertiary carbocation are more stable. So that is why this CH3 shifted to this. There is a alkyl shifting which is occurring here. So this becomes the most stable alkene, tertiary carbocation. After that, there is a removal of the hydrogen. So this hydrogen will get removed out from here, and there is a formation of this major product because it is having a highly substituted alkyl group, and this is having less because on this the one carbon is only substituted, not the second. So next is your intermolecular dehydration forming ethers. So when the dehydration is carried out at a temperature of 140 degrees centigrade with an excess of alcohol, then the ether will be formed. So when there is an excess amount of alcohol is there and this reaction is occurring at temperature 140 degrees centigrade, then there is a formation of an ether. So there this reaction removes a molecule of water from the two alcohol molecules, and this causes the two R groups to form, to become attached to an oxygen atom, and there is a formation of an ether functional group. So here you can see the two molecules of this alcohol is taken, and we are doing this reaction in the presence of this concentrated H2SO4, and there is a formation of this ether is there. The water molecules formed. Next is the halogenation. So alcohol can be converted to alkyl halide using one of the three reactions. That is your reaction with hydrogen halide. So here respective alkyl halides are formed by reacting with the appropriate hydrogen halides, and HCl for chlorination, HBr for bromination, and HI for iodination. The reaction involves the initial protonation of the hydroxyl group of the alcohol, and this improves the leaving group ability of the hydroxyl group. So here the alcohol is reacting with this halide, that is your HCl, HBr, HI, and there is a formation of this alkyl chloride, alkyl bromide, alkyl iodide. So in the mechanism, there is a protonation of the alcohol. The alcohol acts as a weak base and accepts the proton donated by the hydrogen halide. So in this hydrogen halide, then there is a removal of water molecule, and there is a formation of halide through SN2 and the SN1 reaction. So for the primary and the secondary alcohol, it is the SN2 reaction, and for the tertiary, it is the SN1 reaction. In this, there is a reaction of the rate of the reaction, order of reaction in tertiary alcohol, then secondary alcohol, and the primary alcohol. So the rate can be shown by the turbidity in the aqueous layer since the chloroalkane formed is immiscible with water. Next is the reaction with thionyl chloride. So here the alcohol is reacting with the thionyl chloride. There is a formation of the alkyl halide, and the reaction involves the nucleophilic attack of the alcohol on the acetyl molecule, displacing one of the chlorides. So this chloride is acting as a nucleophile in one second step and displaces the oxygen from the carbon and carbon. So here reaction is phosphorus aldehyde. So here in this you are seeing that the alcohol is reacting with the phosphorus bromide or the pentabromide. So there is a formation of this alkyl bromide. So it is the mechanism is also similar to the thionyl chloride. So the alcohol is acting as a nucleophile and it is displacing the halide ion from the this phosphorus trihalides or the phosphorus pentahalides. Next is the esterification. So here alcohol reacts with carboxylic acid, acid halide, chloride and the acetic anhydride to form esters. So here you can see this carboxylic acid is reacting with the alcohol in the presence of H2SO4 and this is a refluxing is happening here and there is a formation of this ester. Next, the alcohol can also react with acid halide and acid anhydride to form esters, and this is known as acetylation. So here you can see this acid and halide, acid chloride is reacting with alcohol, and there is a formation of this acetyl. So next is your question: which one of the following molecule does not form alcohol when react with Grignard reagent? That is the carbon dioxide. Which one of the following alcohol will be formed when methyl magnesium bromide reacts with acetone? That is a tertiary alcohol. Catalytic dehydration of a primary alcohol gives a aldehyde. Chloroethane reacts with X to form diethyl ether. What is X? That is C2H5ONA. Next is your in dehydration of alcohol is an example of elimination reaction. Next, which of the following phenol is not dehydrating? That is your catechol. What is the common name of the simplest hydroxy derivative of benzene? That is the phenol. These are some of the references from where you can study this topic and